right, as we get started, page 285 in your textbooks. Page 285, you did 14 to 22 even on 285 to 286. Practicing with matrices, we had some adding and anyway, all kinds of stuff with the 14 to 22 even. So you'll have that out. You also did 12, 14, 18 back on page 283. We'll get to that in a little bit. Excelente. C. Ja.
Ja.
Ja. German. Ja. That too. Good. Bueno. Yeah, good. Yep. All right, let's take a look. Number 14. Adding those two matrices together, what was your sum, Kendall?
3, 10, negative 8, 2, 11, negative 14.
Good. 3, 10, negative 8, 2, 11, negative 14. Number 16, not trying to insult your intelligence here, but what is the additive inverse of A, Audrey?
Negative 12, negative 15, negative 6, 3, 4, 0, 21.
Well, when we read a matrix, we always go across in rows. So let's try it again.
Negative 12, 4, negative 15, 0, negative 6, 21, 3, 4.
All right, as Michael says, you would consider your intelligence insulted. Change all the signs of A. Nice thing is on the quiz or test, you don't have to read it out loud. So, but still, nice to know how to read them. No, don't. Then cheating. So number 17, it says to subtract, or number 18, excuse me, it says subtract. We're not going to subtract, of course. We're going to add the inverse. And so what did you get for number 18 when you added the inverse, Maddie?
7, negative 11, negative 3, 53, 35, 20, negative 10.
Good. 7, negative 11, negative 48, 53, 35, 20, negative 2, negative 10. Number 20, we're multiplying by that constant value. What's that called, class? Starts with an S? Ends in a scalar?
Oh, scalar.
Scalar. Anyway, what did you get when you multiplied the scalar here, Abby?
10, negative 4, 0, 22.
And Audrey's like, she went down. It was a column matrix. In case you couldn't hear on camera, that was 10, negative 4, 0, 22. All right, number 22. We had to multiply the scalar first, then add the inverse. What was your final answer here, Genesis?
20, go across and down.
Number 22, go across the top row and then go across the next row.
28, negative 12, negative 8, 16, negative 44.
Yeah, that's when you distribute the 4. Looking for the final answer.
I just distributed the 4.
Oh, okay, yeah, so we want to distribute the 4 and then add the inverse. Let's go to Michael. What was your final answer?
7, negative 63, 27, negative 16, 19, negative 15.
Ooh, really close. Brandon?
7, negative 63, negative 3, negative 16, 25, negative 15.
Really close also. You corrected his mistake but made your own. If we could combine your answers, we might get Kendall's answer.
7, negative 63, 27, negative 16, 25, negative 15.
There we go. So on 22, Genesis, yes, we're going to start by distributing the negative, or distributing the 4, and we will get what you gave us for your answer, right? And then we're going to add the inverse. So change the next to its additive inverse, the negative 21, negative 43, positive 15, negative 8, positive 9, and negative 6. And so that's where we'll get to 7 and negative 63. There's the 27 because the signs should both be positive by now. Negative 16, what is now a 27 and negative 50. Is that correct? Negative 25, I can't add. All right, and so I made my own mistake where Michael made his, I believe. And there we go. Questions. I only had this 22 for your answer. Only Kendall. Good job, Kendall. Questions from the rest of you? If I had candy, I'd give you candy, but candy's all in my other classroom.
Consider our intelligence insulted.
Insulted. Okay, there we go. We'll tell you what, I'll give you a chance to redeem yourselves. Go back into the odds, 13 to 21. 13 to 21, the odd there on pages 285 to 286. Reviewing over the basics of matrices. Michael's finished. Maddie's finished. All right, let's take a look at these together. Number 13, what did you get for your answer, Abby?
3, negative 31, negative 4.
Good. Probably should have given that one to Audrey. Number 15, what's the additive inverse there, Genesis?
Negative 3, negative 5, 24.
Excellent. Negative 3, negative 5, 24, 3. By the way, the answer to the last one, I forgot to repeat it. 3, negative 31, negative 4. Number 17, when you added the inverse, what did you get? Audrey?
23, negative 2, negative 83, 2.
Good. 23, negative 2, negative 83, 2. Number 19, when you multiplied the scalar, what did you get? Kendall?
14, 28, negative 21, negative 7, 0, 7, negative 56, 63, negative 8.
That is correct. 14, 28, negative 21, negative 7, 0, 7, negative 56, 63, negative 84. Kind of reminds me of those like multiplication boxes and stuff you did on speed drills when you were in elementary school. Number 21, we had to multiply a scalar, and then we also needed to add, so we didn't have to subtract or add the inverse this time. What did you get for your answer on 21, Brandon?
10, negative 53, 0, negative 35.
Good. 10, negative 53, 0, negative 35. How many got all of them correct? All right, so mostly perfect questions, comments on those. All right, page 283. Go back just a couple pages, page 283. You did numbers 12, 14, and 18, practicing multiplying matrices together. Let's take a look at these. Again, the first thing you have to ask yourself when you're given a multiplication problem, because inevitably on a quiz or test, you're going to be told to multiply, and you're not actually going to be able to. What am I looking for on every multiplication problem right up front? Maddie?
The columns in the first one and the rows in the second one.
Good. Specifically looking how many columns in the first, how many rows in the second, or in general just the dimensions. This first matrix number 12 class was a 2 by 2 matrix. The other one was also a 2 by 2. So of course, yes, because the columns of the first and the rows of the second match, we can multiply, and our product will be, class, another 2 by 2 matrix. Remember, I like to set it up a little bit bigger, and I like to divide into sections. Just keeps me from getting my numbers mixed up. But remember, we're going to take the first row and multiply it, class, by each column. So we're going to multiply here first, and that's going to go in this first spot. Row 1 and column 1 are going to go in row 1, column 1. And what two partial products do we write down, Michael?
Negative 5 and negative 6.
Negative 5 and negative 6 as we multiply these two and those two. Then we're going to go to the same first row, but now the second column. So first row, second column. What two partial products do we write down, Maddie? 10, negative 18. Then we're going to go to our second row because we're done with the first row. And we're going to go to the second, or to the first column. Row 2, column 1. And what are my two partial products, Brandon?
Negative 1, 8.
And then finally, as we take row 2, column 2 to go here, two partial products, Audrey? 224. What do I do with the partial products in here, Abby?
You just combine them.
I'm going to add the partial products in each of the four spots to get the 2 by 2 matrix. What was your answer?
Negative 11, negative 8, 7, 26.
And that's what we should have had. How many had that answer for number 12? Okay, most of you, a couple of you didn't. Questions, comments, did we find our mistake? Any questions at all? All right, let's go to number 14 now. And we've got a 2, negative 3, negative 1, 1, 4, 0, being multiplied by 0, 3, negative 4, 1, 1, negative 2. Again, the dimensions of my first matrix, Genesis. I'm sorry?
3 by 2.
3 by 2, and then the next matrix,
2 by
2 by 3. Can I multiply? And what am I going to get when I multiply? 3 by 3. And so, I'll tell you what, let me put it down here. All right, and so we're going to start again with this first row being dropped down each one of these columns. We're going to start with the first column. What are my two partial products, Genesis?
0, -3.
What are my next two partial products, Kendall?
6 and negative.
Did you say -3?
Yeah.
Okay, and then my last part, my partial products right here.
Is this me?
No, her still.
-8 and 6.
There we go. Now, Michael, let's take the second row and let's get our first set of partial products.
0, 1.
The next set, Maddie,
-3.
and the last set, Brandon.
4, -2.
All right, and then we go to our final row. We're going to go down each column. First set of partial products here, Audrey.
0, 0.
0, 0. That should be easy. The next one, Abby.
12, 0.
And the last one's here, Genesis.
-16, -8.
Careful. Remember, the 4 goes to the -4. The 0 goes to the -2. So
0.
0. And then we're just going to add them together. Kendall, what do we end up with? Let me put it here for our 3 by 3 matrix.
-3, 3, -2, 1, -2, 2, 0, 12, -16.
And there we go. Have we had that for number 14 for your answer? All right, questions on that? Of the 9 elements here, how many did you have correct? 8 of them. So it was just this one? Okay, everything else was good. All right, excellent. All right, and let's take a look at the last one now. It's number 18 from the homework. And we had, oh, lovely. A row matrix, 1, -2, 0, being multiplied by 12, 3, -8, 0, 3, -1, 5, 4, -5, 11, 7, 0, 1, 2, 21. What are the dimensions of these matrices, Michael?
1 by 0. Or 1 by 3. Yeah. And then, a 5 by 3.
Rows then columns.
3 by 1. A 3 by 5.
3 by 5. So 1 row, 3 columns, 3 rows, 5 columns, which is good because that means we can multiply. But our answer is going to be
This is still me?
Yeah.
A 1 by 5.
a 1 by 5 for our answer. So we're going to get another row matrix, but there's going to be 5 spots. I think what I'll do, so I give myself a little bit more room here, and we'll divide it into 1, 2, 3, 4, 5 spots for us to put our partial products. Well, it's obviously this row. It just gets multiplied by each column in its turn. So let's get our first set of values here, Maddie.
12, 2, 0.
Let's get the next set of values, Brandon.
3, -10, 0.
The next set, Audrey.
-8, -8, 0.
Abby, the next.
0, 10, 0.
And the last set, Genesis.
3, -22.
And so, Kendall, when we put them all together, I think you gave me the answer last one, didn't you? And that's just how it worked out. Okay, go ahead.
14, -7, -16, 10, -19.
And that's correct. How many had that for number 18? All right, questions? Question. I want you to do number 20 now at your seats. Do number 20 at your seats. Still there on page 283, number 20. Once you finish, check your answer. If you're good, go back and hit 16. If you're not good, figure out why you're not good. If you're good, go on to 16. If you're not good, either figure it out or, of course, raise your hand and ask a question. Unless you're watching on YouTube, then I just can't see your hand. Screaming at the TV doesn't help either. Stop the bracket. I have to make sure I don't steer people wrong. That was a stupid mistake anyway. Could you go on 16? Give a little time for those who are still finishing up. So if you're finished already, tackle 22. Start on 22. We're going to work it together in a minute, but get your head start on 22 and see if you can figure it out on your own before we go over it. You're still working on 16, no rush. Take your time, get it right. I'm going to erase 20. Seems like we're all good to go there. All right, anyone still working on 16? All right, check your answer to 16 if you haven't already. How many got the correct answer on 16? All right, any questions at all on 16? All right, let's take a look at 22. What are the dimensions of all three matrices here, Abby?
3 by 2, 2 by 3, and 3 by 3.
All right, so you understand we can already multiply these as is, but order of operations says we have to multiply in what order, class?
That's right.
We really need to multiply left to right. So we're going to take these first two, and when we multiply them, class, we're going to get a 3 by 3 matrix. Then we're going to take that 3 by 3, and we're going to multiply it by that 3 by 3. How many already figured out that initial step? All right, so let's go ahead and get our 3 by 3 matrix here. And let me go ahead and break that down here. Remember, multiplication is not commutative, so you need to make sure we're careful to take the order we're given here. What are my, I'm going to have to write them kind of small, so let me see if I can zoom in just a little bit here more for the camera's sake. And I'll move this out of the way. Let's go through partial products here very quickly. Brandon, first set of partial products.
0, 3.
Next set, Audrey.
0, 0.
That was easy. Speaking of insulting intelligence. And what about the next one, Abby?
0, 1.
0, 1. Genesis, the next set.
6. -9.
Good. Next one's Kendall.
0, 3.
Mr. Nebraska, you copied it down wrong.
Oh.
Instead of 2 zeros, there's a 1.
Oh, it's a 0, 1. Okay, well that would explain it. Okay, all right, so it should have been a 0, -1. And this is a 0, 3. Okay, all right, so some were reading off their work. Thank you for catching that. And then the last set there, Michael.
0, 1. Oh wait, we're on the second one. Okay. 4, -3.
There we go. Brandy, continue.
3, 12.
Audrey.
0, -4.
And the last one's Abby.
2, 4.
All right, so what actually is, I'm going to go ahead and put it up here. What is the resulting 3 by 3 matrix then, Genesis?
3. -1, 1. -3, 3. 1. 15, -4, 6.
Good. How many had already gotten that initial product even before we started? Okay, now several of you knew had gotten a head start. Now let's multiply these two together. All right, and again, since I've got a 3 by 3 times another 3 by 3, that final product is going to come out class 2A, 3 by 3. And again, give myself a little bit more room this time, getting our partial products. Kendall, start us off with our first set.
3, -4, and -1.
Good. Next set, Michael.
0, -2, 5.
Maddie.
0, 2, 3.
Brandon. Next one.
-3, 12, -1.
Audrey.
0, 6, 5.
Abby.
0, -6, 3.
Genesis. Okay, we're down here to the bottom row now. So we're going with the bottom row, going down first column.
15, -16, -6.
Good. Next one, Kendall.
0, -8, and 3.
And Michael.
0, 8, and 18.
And then finally, our final answer, the resulting 3 by 3 matrix, Maddie.
2, 3, 5, 8, 11, 3, -3, -7, 22, and then 26.
I'm getting a -5 in this. I'm sorry?
-6.
Okay, somebody said -6. Okay, and I just didn't catch it. That makes more sense. Okay. All right, somebody probably said the negative and I just didn't hear it. I was just kind of copied. Okay, and make sure this is correct before I pronounce it too far. Yes, there we go. How many had this? All right, feel like we understand what we're doing there with the multiplication problems. And yes, it all fit on the camera. All right, turn the page. Number 23, what am I going to have to do first in order of operations here, Kendall?
Multiply. And then
Notice it,
Oh.
right, you see there's parentheses there, so we're going to have to first add them because of the parentheses and then,
multiply.
actually see, let's do number 23. This one shouldn't take as long as the last one, that's for sure. We'll do 23 at your seats. If we're good on 23, go on to 24. If you're good on 23, go on to 24. Any questions on 23?
Is that 25?
That's 25. Huh.
Yeah.
Okay. Thank
I
you.
know the answer to 25.
Yeah, me too now. Sorry, 24. Good call. All right. Yeah, I like that better for 24. All right, any questions 23 or 24? Any questions on how to follow order of operations? All right, look at 28. Order of operations. What are we going to have to do?
Multiply first.
Multiply first. At your seats, do 28. At your seats, do 28. one hand, that's really annoying. You take two nice, easy matrices. This class would be called a column matrix. You multiply it by a row matrix, and all of a sudden you come out with what's going to be a square matrix. The nice thing is it's just one multiplication each time, right? You just distribute the 2. You distribute the -1. You distribute the 0. And you've already got your 3 by 3 matrix. So, not particularly difficult. And since you're just adding these two together, what do we get for our top row? Brandon?
-184.
What about the next row here? Abby?
-110.
And then our final row, obviously Genesis. And there we go, and fact checking. And yep, that's what the answer key has as well. And questions on order of operations. Do we feel like that's pretty manageable also? All right, next in your notes, I want to talk to you about a concept called identity. Identity. Geometry students, former geometry students, don't panic. Identity. Identity concept means basically something stays as it is, right? For instance, if I says, Genesis is my favorite, and I want to help Genesis out financially a little bit here, so Genesis, here's $0. Have I done anything to help Genesis? No. Or if I'm like, I really don't like Kendall. I like Kendall, but I don't really like Kendall, so I'm going to steal from her. I'm going to take $0. Nothing's changed. If you write this down, just as a refresher in your notes, because I think this will help you understand what's coming, the identity number for addition and subtraction is 0. Add 0, subtract 0, nothing has changed, correct? That's not the case for multiplication or division. Right? If Genesis employer says, we really want to reward you, and we are going to multiply your salary by 0. You say, wait, I'm working for free? That's basically what it, right? No, but to leave her pay alone, we would multiply class by 1, or divide by a 1. So for multiplication and division, of course, we understand the identity number is a 1. Well, for a matrix then, we understand to add a matrix, we could either add a 0, or we could add like 0, 0, 0, 0, or if it's like a 2 by 4, right? You get the idea. For adding and subtracting, you just have to make the same size matrix and fill in all zeros, right? So that's really, frankly, not even worth your writing down. But what about to multiply? What about to multiply? We have something called an identity matrix. You can write that term in your notes. Identity matrix. It's used in multiplication. The identity matrix, you need to note this if you would, the size is based on the number of columns in the matrix. The size is going to be based on the number of columns in the matrix. For instance, if I have a 3 by 2 matrix, I would have to multiply that by a 2 by something, correct? Since there are 2 columns in the matrix, I'd have to multiply by a 2 by something. So we're looking at the columns in the given matrix. Well, there are different identity matrices depending on how many columns there are. We have what's called the I1 matrix. It's a 1 by 1 square matrix, and it's the number 1. Because obviously multiplying by 1 changes nothing. The I2 matrix has to be a 2 by 2 matrix because we don't want to affect the outcome of the other. So for the I2 matrix, it's going to be 1, 0, 0, 1. The I3 matrix, well, this is going to be a 3 by 3 square matrix, is 1, 0, 0, 0, 1, 0, 0, 0, 1. Do you see what's happening with the identity matrices? Because if you see the pattern, we don't have to memorize any of these. What's the pattern in an identity matrix?
The 1 moves over 1.
The 1 moves over 1. It's all zeros except you have 1s on what we call the main diagonal. So if you'll put that in, rather than defining it in words, just use the picture here that you've already put down. we have what's called the main diagonal, and the main diagonal will become all ones. Everything else becomes zeros. And if you multiply by an identity matrix, it changes nothing. Okay, let me give you an example. You don't have to copy this in your notes. But let's suppose we had this matrix, a 3, -1, 4, 5, 2, 10. Okay, what's the size of the matrix, class? 2 by 3. So, if it's a 2 by 3 matrix, if I wanted to multiply by an identity matrix, which identity matrix? I1, I2, I3, I4, I5, what?
I3.
It'd have to be an I3 matrix because it has 3 columns. You have to multiply by 3 by something. Again, multiplying by a 3 by 3 matrix is going to allow you to multiply, and it's going to leave you with the same dimensions you started with. Does that make sense? So what is the I3 matrix? Well, we said the main diagonals are 1s, and everywhere else, class, we get zeros. Well, watch how this works then. When I multiply, I take my top row, drop it down to first. I get what partial products, class?
3.
Or in other words, 3. Then I get 0, -1, 0, which adds up to -1. Then I get 0, 0, 4, which adds up to 4. You see how it's leaving everything alone. With the next, I'm going to drop this down and I get, or 5. Then I get 0, 2, 0, which adds up to 2. And then, of course, 0, 0, 10, which adds up to 10. Notice an identity matrix does not change the value, hence the term identity matrix. Just like an identity number doesn't change, identity matrix does not change. Do we see how an identity matrix would theoretically work? By the way, what would, just for fun, what would the I5 matrix look like? Maddie? In case you couldn't tell what I meant by main diagonal, hopefully the I5 matrix makes it really obvious. We all see main diagonal, zeros everywhere else. Okay, page 284, look at number 31. Look at number 31. It says to multiply each matrix by the appropriate identity matrix. No, I'm not trying to insult your intelligence this time. But for number 31, they give us a -2, 4, 1, 5. Which matrix would I have to multiply by? Class? I2, because this is a 2 by 2 matrix. That's the only number I care about. We're going to multiply by the I2 matrix. What is the I2 matrix, Genesis?
1, 0.
There we go. And so we multiply by that. And again, we could do a little crisscross thing here if we wanted to. What are my first two partial products, Kendall?
-2, 0.
My next partial products, Michael?
It equals 4. Yeah, 0, 4.
Then the next one's Maddie.
1, 0.
And then the next one's Brandon.
0, 5.
0, 5. And obviously you can see you're going to get what class? -2, 4, 1, 5, right? The same thing you started with. We can do the same thing on 32 for practice. Go ahead and do it. Number 32, multiplying by the identity matrix, the I3. If nothing else, it also gives you practice with keeping track of partial products. But you already know the answer, right? It's like practicing multiplication, but knowing the answer when you start. So not entirely a waste of time exercise that benefits. Make sure you've got that 1 in the main diagonal, zeros everywhere else. And when you get your answer, it better look like number 32. If it did, you did it right. We're checking our answers, making sure it's the same thing as in number 32. All right, questions at all? All right, that brings us to this topic then, the topic of inverses. Inverses. Obviously, there are different types of inverses. One of them we've already referenced, and that's what we call additive inverses. This is usually what we think of when we talk about inverses, something like a 5 and a negative 5. Well, matrices, we've already looked at additive inverses, haven't we? We said the additive inverse means you change the signs of everything. But there's something else called a multiplicative inverse. Now, an additive inverse is that which gives you a 0, correct? If you added 5 and negative 5, it would equal 0, wouldn't it? Multiplicative inverses don't equal 0. The multiplicative inverse of a 5 would be a 1/5. Well, if you multiplied those, you wouldn't get 0, class, you would get 1. The reason here is that additive inverses give you the additive identity number, which is 0. Multiplicative inverses give you the multiplication identity number. So here's the key. Are you ready? This is where it all kind of comes home. It's kind of like, okay, duh, a lot of easy stuff. Here's the key. Multiplicative inverses then must produce the identity number. That means that multiplicative inverses in matrices must produce the identity matrix. Does that make sense? Multiplicative inverses are simply reciprocals. But for matrices, a multiplicative inverse, write this down, produces an identity matrix regardless of order. Now that's new, because multiplication is not commutative. But if they're inverses, the order won't matter. For matrices, multiplicative inverses produce an identity matrix regardless of order. For matrices, multiplicative inverses produce an identity matrix regardless of order. All right, so this is where the identity matrix really comes into play, is determining whether or not you might have multiplicative inverses. For matrices, multiplicative inverses produce an identity matrix regardless of order. Look at page 282. We're going to work on this more tomorrow, but I want to show it to you today. That way we kind of get a feel for what's going on. Look at example 6.2f. 6.2f. They give you these matrices, 2, 5, 1, 3. That's matrix A. Matrix B, you see there is 3, negative 5, negative 1, 2. Well, they went ahead and multiplied matrix A times matrix B. They just did their partial products instead of stacked. They did them side by side. 6, negative 5, negative 10, 10. 3, negative 3, negative 5, 6. And notice the matrix that was produced was 1, 0, 0, 1. Well, that's an identity matrix. Then they multiplied it the other order, B times A. So they flip-flopped them. Well, now your values, 6, negative 5, 15, negative 15, negative 2, 2, negative 5, 6, gives you once again 1, 0, 0, 1, an identity matrix. So that means, yes, those two matrices, A and B, are multiplicative inverses, because no matter which order they are multiplied, they produce an identity matrix. Does that make sense? Look at the example below it, though. 1, negative 2, 4, and 2, 1, 1, 1. Well, they multiply A times B. You get the partial products, right? 2, negative 1, 1, negative 1, negative 4, 4, negative 2, 4, and it produces 1, 0, 0, 2. Is that an identity matrix? No. And it doesn't take the time to show it, but if you multiply B times A in the flip-flop order, it still wouldn't produce an identity matrix either. But those are not multiplicative inverses, because when multiplied, they don't give you an identity matrix. Make sense? That's more a concept for tomorrow. Nothing in your homework this evening is going to review over that. For homework this evening, we want you to do pages 283 to 284. Pages 283 to 284. Do numbers 21, 25, 26, and 27. Pages 283 to 284, numbers 21, 25, 26, and 27. And we'll leave it there. We'll call that good. Just 4 problems for homework this evening. Have a wonderful rest of your day, and we'll pick this up more tomorrow.